This is Between the Brackets, a MediaWiki podcast, episode 11, June 26, 2018. Welcome to Between the Brackets. I'm Yaron Koren. This is a very special episode of Between the Brackets because my guest is Markus Krötzsch. Markus is a professor of computer science at the Technical University of Dresden, where he heads up the research group dedicated to knowledge-based systems. He is also the co-author of the 2009 textbook, Foundations of Semantic Web Technologies. But to anyone in the MediaWiki community, he is better known as the co-creator of the Semantic MediaWiki extension, which came out in late 2005, and a key player in the creation of Wikidata, a site launched in 2012 that, if you believe many people, will one day serve as the main data backend for Wikipedia. He created both with Denny Vrandečić, whom I hope to have on the show at a later date. On a personal note, I got into MediaWiki via Semantic MediaWiki, so it's fairly safe to say that if it weren't for Markus and Denny's work, I would not be here running this podcast. More generally, the current community and set of software around the use of MediaWiki outside of Wikipedia and its related sites, a world I like to refer to as Enterprise MediaWiki, very much grew out of the community that formed around Semantic MediaWiki starting in 2006. So though we can never know how things would have turned out differently, it's possible that if it weren't for Markus and Denny's work, there would be no significant community of MediaWiki users outside of Wikipedia and the rest, any more than there is, say, a TiddlyWiki community. From 2007 to 2012 or so, Markus and I were both heavily involved in the Semantic MediaWiki project. I stayed on a few more years after that. During that time, we also, to some extent, started the SMWCon conference together. I helped create some of the first few SMW-related events, and Markus came up with the name SMWCon and also created the Open Semantic Data Association, or OSDA, a German nonprofit that, among other things, handles the funding for SMWCon. OSDA still exists, and Markus is still the president of it. Markus and I haven't talked in a while, except for the occasional email relating to organizational stuff, so I'm very glad to be talking to him now. So Markus, welcome to the podcast.
It's my pleasure. Hi.
I want to start at the beginning, I guess. Everything you've done professionally, that I know of anyway, is in some way related to the study of data structures. Looking back, was there something in your youth or early adulthood that sparked your interest in data?
Not specifically, to be honest. I actually have to say I'm more interested in content than in the structure of the data as such, in many cases. So I always was fascinated more by the applications that we get from the data than by the mere technical view of data as such.
Oh, that is interesting. Obviously, I want to talk about Semantic MediaWiki. What I think a lot of even people who use SMW don't know is that it started out as basically the first attempt at Wikidata. Could you give a brief explanation of how you and Denny came to create SMW?
Right. So this was back in 2005, I guess, when the first Wikimania conference was scheduled. So this was the first Wikimedia event ever. And by chance, it was scheduled to happen in Frankfurt, which was very close to our location at the time in Karlsruhe. So Danny and I were big Wikipedia fans, which was not such a standard thing in these days. So many people didn't even know Wikipedia yet. And because it was so close, we just thought we have to go there and do something. So we get together and thought, well, what can we actually make or contribute based on our research, based also on our technical expertise that would somehow be useful for Wikipedia as such. And since we were in a semantic web research group and just had it started working on our PhD thesis there, we thought, well, why not do something which has to do with machine understandable data and how you can help people work with Wikipedia based on whatever machine intelligence you could offer based on this. So the very naive idea was that as soon as you made some even small part of Wikipedia machine readable, wonderful things would happen and automatically somehow things would fall into place and applications would emerge and the world would be a better place. And so with this idea, we just went to Wikimania and said, here's our idea. Let's annotate data. Let's have some machine readability there. And it's going to be a little project. It's not going to make a lot of difference to what you're doing now. And in a few days, a lot can be accomplished there. And we gave a talk on this very idea, without any intention to implement anything ourselves, to be honest. So we didn't have any experience in PHP or any of the software underlying Wikipedia. So we definitely didn't want to start a software project with us as the developers. We rather thought of this as an initial idea, right? And Denny, who gave the talk at this time, explicitly asked the audience for help and for support, and asked people to come forward to help implement this idea in MediaWiki. And we were lucky that somebody actually did that. So the company DocCheck at the time approached us and said, well, what do you think? How much time will it take to realize? And we said, well, maybe 2-3 weeks of development time. and this is how it started. It wasn't 3 weeks in the end, but that at least was our beginning.
Yeah. I find that so interesting that it started sort of just on a lark, I guess, or coincidentally. Again, there's no way really to know how things would have turned out differently, but you're still, of course, interested in Wikipedia and applying data structures. Do you think you might have, in some way, gotten to that anyway?
Well, I don't know. Frankly, I mean, you emphasize coincidence as if it were an unusual thing, but to be honest, I think most of what we do and achieve is coincidental, right? We might always have achieved something, but maybe very different from what actually happens. So, yes, it was a coincidence, and there could have been other worlds with other developments, but I won't speculate how they might have looked.
No, that's very true. We definitely we assign meaning to things that don't necessarily merit that kind of meaning. But so in retrospect, it seems obvious that Semantic MediaWiki was not an ideal solution for Wikipedia, and that what Wikipedia needed was a separate data store not tied to any specific language, rather than adding annotations to a specific language of Wikipedia. At the time, everyone thought that SMW was eventually coming to Wikipedia, maybe because that was the only tool available. Do you remember when you sort of gave up on that idea?
I couldn't say, no. I mean, it was rather replaced by the other idea. I think there are many reasons why it's better to have semantic data standalone rather than annotated. And one of the big reasons, of course, is that in this way you can make the data truly language independent. You are not tied to the form of any particular article in a particular language and then have to search for occurrences of a certain number just to be able to have it as data. Rather, you can just say this number is relevant to this subject and you can add it without having to rewrite the article, which seems to me now as a rather artificial task. So in this sense, I think it's clear that it's a better approach to do it like this. The idea for this is something which I would personally attribute to Eric Möller, who has had a lot of influence on this part of the design, and who had already thought about Omega Wiki and related projects for many years. And we have been talking to him a few times over the years related to how to make semantics be a part of the Wikimedia cosmos somehow. And his approach was really to have a centralized repository. And we eventually were convinced that this is really the better idea.
Yeah. And that was 2010, 2011, something like that. When that I guess it was originally known as Shortypedia, or there was a demo site.
Shortypedia was actually something quite different. I wouldn't be able to tell you the details off the top of my head now, but it was not meant to be a demo for semantic Wikipedia or Wikidata or whatever it might have been in the end.
Oh, okay. So it's back to SMW. While we were all waiting around to hear back from the Wikimedia Foundation people about whether they wanted to use SMW, there was a boom of interest from people starting to run it on their own personal and business wikis to do their own data management. Were you surprised by the interest it got?
Oh yes, absolutely. So this is always amazing. I guess this is something that happens to many people in open source when you develop a project and suddenly it turns out that some people somewhere actually find it's useful and invest in it and contribute to it. And so this was great, yeah, and it was surprising because of course there's no role model for this type of development. So you basically start blindly because you think it's useful and you use it for your own purposes, and you basically make an agenda for a project based on what you think is useful. And if somehow this resonates with people out there with use cases that you have never thought of, that's of course an amazing situation, and really has helped a lot to shape the project in the upcoming years. So this input from other users was really important to us, and also was important for the motivation needed to really do this for so many years and invest so much time into development and so on. So this was great, but really unexpected.
Yeah. Well, that ties into my next question. So you accidentally became the head of a small to medium-sized open source software project. Denny was, of course, also involved, but I think you were pretty clearly the head. I'd say you're still the head now in the sense of being a quote-unquote benevolent dictator for life, even though I don't think you've tried to have any say. I'm guessing you've heard of that term.
Yeah, sure.
Yeah.
I don't know. I mean, we are not as organized in this sense that we have a dictatorship or even a state that can be ruled by a dictator or by anyone. So in this sense, I don't perceive myself very much as the head of anything right now. I think the development is pretty self-reliant, and people driving this, in particular James, who is doing this for many years now, they are pretty independent, and I wouldn't even as a friendly dictator would not dare to tell them what to do next in this project.
There is something to that, yes. Maybe you're more like a Queen Elizabeth figure.
So yeah, with the waving. Okay, I can practice this. Yeah. No, but it's true. Of course, there's always some attachment. When you have started a project, you are never going to be completely detached from it. But I still very much respect the work of the contributors who have taken over the project since, and I think they have good judgment of what is needed and what the right technical steps are to be taken next. Yeah.
I did want to ask one brief question associated with that, which is when you were directly running SMW, did you end up taking inspiration from any other projects as far as how to run an open source software project? Or is it just sort of ad hoc?
I think it was pretty ad hoc, to be honest, which I'm not claiming was the right thing. I mean, one could maybe have learned something from other projects, but then it's difficult to find a project which is of the same scale and scope and community structure so that you can really take over the processes. It's like companies too. Any company can be run in very different ways and can always be successful. So it is, I think, not so easy to find good patterns of operation for a new project. It has to find itself, and it really depends also on the team structure. With SMW, we always had a very small core team of developers. And this requires a very different way of working than when you have a bigger team of contributors whose contributions need to be reviewed more than by the core, rather than the core being the ones who do most of the coding in all cases. So that's very different, and I think we never got that big. So the SMW core, also because of the extension mechanism that exists around MediaWiki, could always stay rather focused and rather small, which I think helped.
Yeah, absolutely. Yeah, I don't remember any big arguments or religious wars about syntax and that kind of thing. No. So switching topics, Wikidata, of course, came out in 2012. But for that one, Denny took the lead on it. He went around and got the funding for it from Google and others, and he served as the project lead on it for the first few years. What was your involvement with Wikidata?
Oh, right. So, yeah, as you said, it was really Denny who pushed that and who continued to believe in it being possible when many people, including myself, had not spent so much time and energy anymore on it. After all, it had been so many years since we tried that, and it didn't look as if it would ever happen. And so it was great that Denny was pursuing this, and he found some windows of opportunity which really made it seem possible again, and then took the chance and went for it, which was really good. Now, what was my role? I actually was part of the initial design of the software and data model in particular, and the platform which was created then based on this. So before the project team actually came together, and even before all of them were hired, we had meetings in Berlin at the time for discussing what should be the scope of the project, what kind of design decisions we should make, how the data should look in particular, that people could enter there. And of course, we started with the ideas of Semantic MediaWiki, where we had a notion of property and a notion of value assigned to some object via a property. So this would be a basic skeleton for data, but an important outcome of the initial discussions was that we also needed a deeper structure for Wikidata, which involved the possibility of adding what is called a qualifier now in Wikidata to any kind of statement. So, for example, when you say that a certain country has a certain population, you can additionally attach to this claim that this is valid at a particular time, and maybe was measured in a particular way by estimation or by census. And we discussed that initially. We discussed, is it maybe enough if we just have times for some statements and nothing else, or just locations and times? But after a few days looking into Wikipedia and actual usage in info boxes and the data we found there, we realized that a simple property value model as we had it for Semantic MediaWiki would just not be enough to capture most of the data in Wikipedia because it was so rich. And this is how the qualifiers came into being. And so this was one of the major design decisions that we had to take in those days, basically, early on.
Yeah. In the time I've known you, you've gone from being a PhD student all the way to now being a full-time professor for the last 2 years, I think. Could you describe the type of research you and your group are involved in?
Well, the chair I have is the chair of knowledge-based systems. So in general, we are interested in building computer systems that handle knowledge, that evaluate knowledge. And this somehow stretches from the very practical aspects that you may have in a system like Wikidata, and some of our research is still related to Wikidata and its usage, all the way to more foundational topics on how to represent knowledge in computers in the first place. So how would you actually encode human knowledge in a computer in such a way that it can effectively work with it, and that it can be maintained in a suitable way, and that it can be evaluated and reasoned with in a suitable way.
According to a web search I ran, 2 of your most recent papers are titled Preserving Constraints with the Stable Chase and Deciding Universality of PTNFAs is P-Space Complete.
Right.
I know that there's sort of a direct line between what you were doing with SMW and Wikidata and what you're doing now, but it still seems like a world away from when you were, trying to get queries to run faster.
Yeah.
Did you ever consider sticking with software development?
No. I mean, you mean as a full-time developer or something?
Yes, if you got bitten with the software bug.
I love coding, and I would like to have more time for it. It's a pity that it's such a time-consuming activity, and there's so little time left in the job. But at the same time, I also love more conceptual work and design work and work where you actually learn something new, something that may not have been known before. And well, the works that you just mentioned, they are particularly theoretically minded. So these are computer science theory works about aspects of computational complexity and aspects of algebraic properties of certain computational structures, which are quite abstract, right? So these are not immediately implemented or implementable, possibly even. So this is one end of the spectrum, but it's a privilege to have the freedom to engage in these theoretically or foundationally interesting topics mathematically, and at the same time to create software or applications which real people use in some place. So I like to switch back and forth actually, but I still have to find the one place where everything comes together.
Yeah. What's an example of something more practical that you've looked at, or you and your team?
Well, so recently an upcoming work that you cannot find yet in Google maybe, but you could find on our webpage, is on the analysis of Wikidata queries and also in general on the Wikidata query endpoint, which we have authored recently with with Stanislav Mališev, who is the main developer of the query service at Wikidata at Wikimedia Foundation. So this publication is entitled "Getting the Most Out of Wikidata: Semantic Technology Usage in Wikipedia's Knowledge Graph." So that's a very practical paper where you can read a lot about how to set up a large-scale query engine, what kind of infrastructure is used if you want to serve millions of users in complex queries every month. And also a lot of experience about what we've actually seen in the real-world queries that we are getting there. So we had access to the real-world query logs of Wikidata users who have used this endpoint. And we then tried to make sense of them and tried to find out what kind of usage patterns do we see and how real people use this data in practice. And that was quite interesting.
Yeah. Okay, cool. Now that you're a researcher, do you feel like your experience with Semantic MediaWiki and Wikidata has affected your views on data storage or your current research in any way?
My view on data storage.
Well, specifically, I'm wondering. Well, one big thing I was wondering about is the concept of well-structured data. In the very beginning, Semantic MediaWiki was built as just a tagging system where you could basically put any property tag around any value. Is the cousin of or whatever else. But then people started putting property tags just inside templates, and my page forms extension, which was then known as semantic forms, I think speeded up that process. And it added even more structure as far as a restricted set of values for fields and so on. Do you think that changed your views on the value of having a predefined data structure?
I'm not sure I would say changed my views. I think over the years, definitely I've learned a lot of what is important and what is useful. And it was also a kind of a backwards process. You first do a software project and it starts to grow and people use it. And only later on you start to understand why it was useful to people. What was its special power as compared to other solutions that had been around at the time. And right, I think one thing where Semantic MediaWiki has always been special was that you could use it in a unique way for prototyping data-driven websites. So you could create websites which are built on top of data, but in a way where you do not have to know upfront what your data structures are in detail. So it was very different in its approach from traditional relational database applications, maybe where you would have a certain schema and you have a certain table and the table has certain columns and that's what you store there. And you know that up front, and every object of this type has these data properties and every object of that other type has these other data properties. Semantic MediaWiki was not like that. It always considered properties as the first class citizen and allowed you to add properties to any object you like. Now that of course creates some, is a bit vague, right? It makes it hard for people to use if you only give them that. And then, as you said, what came along was this notion of template-based editing of forms that was, of course, mainly your achievement of getting this to work, which allowed people to create input masks that would suggest which properties to use. And would enable them to just use a certain set of properties and make it much easier for them to find the right properties for a certain type of objects and also to format them in a meaningful way. But
Right.
What was really great, I think, was the combination of both. Because today, when I start a Semantic MediaWiki site, I can just make a simple form, a simple type of object, and I can start using it and add users to it, and they can start using it. And then if in a month or so, I suddenly realize I need another property in this object, I just add this property to the site, I change the form a bit, so suddenly it will have a new input. And Semantic MediaWiki is completely fine with that. So I don't have to change any schema for this. I can just dynamically add and also remove data. And even in the running system where I already have objects, it will not cause any problem. I can handle this. So this flexibility, I think, is a really strong point. That you are not locked into a rigid form, which is just based on a single table structure, but you can somehow grow from a given object model, which is on top of the actual technical data model underneath. So the technical model does not constrain what you do in your application. You can change it later on. I think that was very useful.
Yeah, sure. I have to ask now about the cargo extension. That's an extension that I came out with in 2015, which is sort of a competitor extension to Semantic MediaWiki. I've mentioned it. I feel like I've mentioned it a lot on this podcast, but as a side note, in a broad sense, that makes us the heads of competing software projects. Although I certainly don't think of it that way, and I
Yeah.
I don't think you do either. Yeah. But tied into what you're saying, Cargo is interesting because it stores its data in a relational table-based way, whereas SMW stores its data in a graph-based way. Although with Cargo, the tables can be created and regenerated on the fly, so it keeps it has some of the flexibility. You're not locked into a certain database structure that you then have to ask a database administrator to modify for you. And this maybe to some extent ties into your general research, just the idea of tables versus graphs. I know in theory you can do everything with tables that you can do with graphs and vice versa, but do you have any thoughts about the relative merits of those two approaches, both in general and specifically in MediaWiki?
Well, there are different levels to this, certainly. I think the primary level of this discussion is one of physical data storage. So one where you discuss how to actually keep bytes on a low level on a spinning disk or in a solid state drive or in memory maybe, in order to work with them. And I think this issue is one which is increasingly irrelevant to users and should be, because our systems now are fast enough, our computers are efficient enough to handle some inefficiency in data structures. So only if you have truly extreme demands on throughput or on the type of queries that you process will you really have to worry too much about the data structures. So in this sense, I think data structure-wise, you can be quite relaxed about that. Of course, somebody in databases would rightly say it's not a physical layout, right? Physically, you still have very different data structures, which are even more fine-grained. You may have some kind of B+ trees or whatever to store data. And you may have the same physical data structures in a graph database that you also have in a relational database.
Sure, yeah.
So
in
this sense, there's not a big difference. I think conceptually, the huge difference between graph databases and relational databases today still is that graph databases consider navigation in the graph to be a key data access primitive. So you want navigational queries, graph searches, reachability queries as one of the fundamental building blocks of what you can look for in this data. And this is something which is very important in Wikidata these days, for example, where many queries are using property paths of Sparkle, which are exactly the part of Sparkle that allows you to check for the reachability of something. Can you reach going through the graph edge by edge from one object another object? And this type of query, of course, in principle, with some restrictions, can also be executed with SQL. but is usually not what a relational database system is truly built for. And so I think this paradigm shift in how you access the data, how you evaluate the data, is that you suddenly evaluate it as a graph instead of evaluating it just as a table and another table. This is something that really makes a difference between these approaches.
That's true. I have to say, on a personal note, I've never really. It's the whole idea of graph traversal has never really appealed to me, and mind maps and all that kind of stuff. I'm more used and more interested in sticking with one quote unquote domain and a table of information and browsing and filtering on that as opposed to jumping from one type of item to another. But anyway, that's there's lots of things you can do with data, of course.
Yeah, I don't know. I think mind maps are a very, very different issue, of course, from your standard graph database. Mind maps are usually an actual graphical depiction of a graph, whereas a graph in a database is usually something you really don't want to see graphically ever, because it's huge. And so Wikidata, for example, is about 500 million edges large graph now, and you're not
right.
going to display this anywhere, not even in small excerpts. And the graph thing, of course, often is confused with graphs as a visualization technique, and this is really not what people mean.
Oh, that's interesting. Because when you talked about graph traversal, I just the thing that immediately came to mind was mind maps, where you can see nodes and the connections between them.
Yeah. So what I mean is with graph traversal is that you can search in a graph by doing something like depth first search or breadth first search, finding connections between objects and without specifying how far away they are. And this is very important for navigating conceptual hierarchies and taxonomies, for example. So if you have a class hierarchy where a thing is not, where your world is not just partitioned into a fixed number of distinct types, basically corresponding to tables in a database, but rather you have more specific and more general types, and more specific types even still beneath the specific types, then you have to somehow navigate this hierarchy. And the hierarchy can also be a hierarchy with multiple inheritance. So for example, you can have a person as a very general type of thing, but a person can be a musician, which is more specific, or a person can be a scientist, which is also more specific. And of course, you will have cases where somebody is both a scientist and a musician, and you still want to represent that. And this can nicely be done in a hierarchical approach. But to work with hierarchies in a distributed system, in a sense that it's authored in a distributed sense, you have to have a relatively robust type of graph search mechanism, which allows you to navigate graphs even if they have cycles, because if you have many editors working on a hierarchy, you can be sure that there will be cycles, and the system should of course not blow up if this happens. So basically what you're simply doing is you follow edges in the graph until you find another node of a certain type. For example, if you're looking for all persons, then you will go from person downwards to all the subclasses of person, and for all these subclasses you will look at all the instances, and that's in this way you will find all the musicians and all the actors and all the scientists, which is of course just one way of doing it. Wikidata, in spite of its heavy use of hierarchies and path queries, is actually not using a big class hierarchy on people. Everybody is just a human, which also has its merits. But hierarchies appear in many places. They appear in science a lot. You have, for example, in biology, in zoology, you have famously the hierarchy of the living things. You also have hierarchies when it comes to classifying professions, for example. And of course, you have hierarchies when it comes to parts and whole relationship in compound systems, which consist of many smaller and smaller parts. If you want to find out if something is part of a big system, you may have to navigate a long chain of part-of relationships. Right, so all of this exists, and this is where graph databases are usually more robust when you want to ask such queries as compared to traditional relational systems. But I think in the midterm, all of this will merge and we will be used to having these features in a data management system. And we will not have to choose upfront whether we want to have a relational or graph-based or whatever else as a system. But it will increasingly be the case that systems will just support the needs of the user.
Yeah, that makes sense. Finally, it seems like you've been thrust into the role of an emissary for Wikidata, given that you're, to some extent, one of its co-founders. You gave a talk a few months ago about Wikidata during the 2018 Wiki Workshop, which was part of the web conference in Lyon, France. I'm guessing that those kinds of speaking requests will only increase as Wikidata gains in popularity. I'm just wondering, does it feel at all strange to be both representing Wikidata and also researching it? In other words, is it strange to be both an engineer and a scientist in some sense on Wikidata?
Not at all, actually. No, I'm enjoying these kind of opportunities. And I really find Wikidata fascinating also from a scientific point of view. So when I talk about Wikidata, I don't just talk about it as an engineer or as somebody who has designed some of the aspects there, but always also as a scientist who is interested in how the system develops. And it's really a unique system and a unique experiment, if you want, just like Wikipedia, where nobody really upfront can tell how it's all going to develop and how we are going to overcome the problems that we still have in many places, and what kind of technologies might play a role there, and also what kind of community mechanisms might play a role there. So I think it's a fascinating topic. And personally, I could also spend all day just editing Wikidata as a contributor because I find the content so fascinating. So in this sense, it's just enjoyable to have this overlap with the application and the science in your profession somehow. So I won't complain.
Yeah. Are you an active Wikidata contributor, by the way?
I think active is when you have more than 10 edits per month. This month I might.
Okay.
But not always. I mean, as I said, it's a question of time. And usually I am more interested in going deep than in going broad and wide. So some people make thousands and thousands of edits by importing something. Usually right. I'm more interested in having a single statement fixed and properly sourced in order to clarify something which is maybe of particular interest. So I'm not importing large-scale databases in this sense.
Yeah. Very good. Well, I think that's all my questions. It was great to talk to you, and I'm glad this podcast was served as an excuse for that. So, Markus, thank you very much.
Thank you. It was very nice talking.
This has been another episode of Between the Brackets. Thanks again to my guest, Markus Krötzsch, and thanks to all of you for listening. I'll see you next time.